Hey, I'm Rishik, and this is ArbScanner. It scans prediction markets for arbitrage across Polymarket, Kalshi, and Manifold. It has two front ends, one MySQL database. I've got the terminal and aliens covering the web app after me. So this table is what you see on launch. Every row is an arbitrage opportunity, event name, which exchange it's on, the profit margin, everything. This is a 5-table join under the hood. Arbitrage alert to market mapping, to event for the title, then market and exchange to pull in which platforms list it. Exchange names get concatenated into one cell, sorted by margin, best opportunities first. When I press enter on any of these ARBs, clicking into an alert, it gives you the full breakdown. Bigger join this time, 8 tables, same 5 from before, plus the binary market, contract, and price snapshot. There's a subquery grabbing the most recent price for each contract. So this menu book, what each exchange is charging for yes and no, that all comes back from one query. Pressing S opens the SQL inspector. It loads our queries file, runs them against a live database. SQL is on the right, and the results are at the bottom. Let's go to the query number 6. This is a division query. It tells basically which events are listed on all 3 exchanges, because you can only arbitrage across platforms if the event exists on every one of them. This is relational division, the double not exists pattern. It filters out any event missing from one exchange. Let's run this. These are where the arbitrage is actually possible. Let's move on to the aggregation query. It's a summary of all active alerts, how many, smallest margin, largest, the average, one row, whole picture. Same kind of query that drives the stat cards on the dashboard. Aggregation with group by now. Same kind of summary, but broken out per exchange. So now instead of one row for everything, you get one row per platform. How many markets does Kalshi have, and what's the average yes price in Polymarket? This helps you figure out which exchange has the most coverage and where prices tend to be lower. That's where you'd want to buy.
I'm Alien. I build React frontend. Both this and Rushik's terminal hit the same MySQL database through a shared Python backend. Fast API serves the API and the React app consumes it. Here's the alerts page. Same join query Rushik just showed. The API alerts endpoint calls alert service list alerts, which runs the exact same 5-table join with group concat. The React app just renders it as cards instead of terminal table. Up here on the dashboard, the stats, active alert count, top profit margin, total snapshots come from the aggregation query. Count star, max profit margin, all through the API dashboard stats endpoint. Back on the main page dashboard, we also use group by queries. For example, this markets per exchange section aggregates market counts grouped by exchange ID. And the activity charts are also based on group data over time. Same queries, same backend service, different rendering layer. The database work is identical, the front ends just display differently depending on the user.
2 more query types. Number 9, this is the update query. This one updates an alert status. You can see in the preview, it wraps the whole thing in a transaction. It changes alert 1 from active to resolved, then queries it back to confirm the change, then rolls back so the data stays clean for demo purposes. In actual use, when it dismisses an alert from the dashboard, the backend runs the same kind of update, but it commits it for real this time. Now, when I press enter, its status changed, and the rollback already ran behind the scenes, so the data is back to normal. Let's move on to the next one. Delete with Cascade. This one shows what happens when you delete something that has related data attached to it. Contract 13 has a bunch of price snapshots. Those are historical prices we've recorded for it. Look at the SQL in the preview. It counts the snapshots, it deletes the contract, then it counts again. Here's the thing. We never told the database to delete the snapshots. The foreign key on price snapshot, it's set to Cascade, which means when the parent contract gets deleted, the database automatically cleans up everything that depended on it. Let me run it now. See, 0 snapshots left. The database handled that cleanup, not our code. And again, the rollback puts everything back. Last piece, we have 3 triggers running in the background. One calculates the bid-ask spread automatically whenever a new price snapshot comes in, so the application doesn't have to do that math. One detects the arbitrage on its own. Every time a new price lands, it checks if you could buy yes on one exchange and no on the other for less than $1 total. If you can, it creates an alert. And the third one keeps an audit log on any time an alert status changes, that gets recorded. On top of that, 6 check constraints make sure that the data stays valid. Prices have to be between 0 and 1. Bid can never be higher than the ask, and status has to be active, resolved, or expired. The database rejects everything that doesn't fit those rules. That's our implementation. Thank you.
Last piece, responsive design. The React frontend adapts to different screen sizes, Cards reflow, navigation collapses, tables scroll horizontally on smaller viewports. Rushik's terminal UI handles this too. Textual auto adapts to terminal width and the layout reflows. Both interfaces satisfy the responsive requirement, and both hit the same normalized 3NF MySQL schema with 8 tables, 3 triggers, 6 check constraints, and all 6 query types we just walked through. That's ArbScanner.